We are now going to have a look at the latest new features of Meta in the recently released version 21.x. As usual, the developments span over a broad range of areas, both for general post-processing applications and in terms of more discipline-oriented approaches. Let's have a look at these one by one. Starting with graphics, we have now introduced 3D models which can act as environment models. These are loaded through the rendering menu options, and their file format may be FBX, OBJ, or MetaDB. The environment models are rendered with their photorealistic properties, and what makes them special is that they are unaffected by common actions we do on finite element models, such as exploding or changing the display styles, unless they are converted back to regular models. Extra realism is achieved if the 3D model is accompanied by the respective HDR environment of the scene used. This way, the loaded models and the respective HDR files may be saved in the same MetaDB, which can then be reused. Furthermore, it's now possible to visualize cast shadows on models and on environments. Each individual light can be set to cast shadows, which are updated as the positions of the lights change. These shadows have configurable intensity depending on user preference. And it's noted that the existing functionality of ambient occlusion introduced a couple of years ago is recommended to be used in combination with these new shadows for more subtle effects around details such as holes or openings. There have been enhancements in the visualization of 3D spheres. Airbag particles and discrete element spheres can now be drawn with their real radius based on a loaded label of results. All elements drawn as spheres, so max, hexa elements, and now airbag particles and discrete element spheres, can be drawn either in pixels or in model units with constant or value-dependent radius. On top of that, there has been significant performance improvement in the visualization and handling of these elements visualized as spheres, reaching up to 8 times faster visualization. And last but not least, the graphical user interface of the settings options has been redesigned so that there are separate tabs with settings for each type of element that can be drawn as a sphere for a better handling and control. Now, regarding performance, the visualization of 3D vectors has been enhanced, resulting in 15 times improvement in performance. So shortly after the support of 3D vectors in the previous major versions, their performance is much better now. In addition, in past versions, when the option smooth light was on or we were in render mode, the first animation loop was slower in comparison to the next. Now, smooth light calculations are GPU accelerated, therefore leading to faster animation loops, both the first one and the ones to follow, leading to performance improvement with less memory consumption. Now, moving on to model and results handling. First and foremost, there has been a major restructure regarding settings and their handling in Meta. We now have a new directory-based structure where graphical user interface settings are saved in XML files, and there are separate subfolders for settings, fringe bars, toolbars, and sessions. Fringe bars are saved in XML files in the subfolder fringe bars. Meta session commands that should be executed on startup are saved in a main.ses file in the subfolder sessions. Toolbars are saved in .toolbar files in the toolbars subfolder, but their definition remains exactly the same as before. And all Meta general settings, apart from the GUI settings we mentioned already, the rest are now saved in a meta.defaults file, which follows a key value text format similar to ANSA. for so it's easier to be read and edited. On top of that, there's a common interface to save and restore default values from the various meta tools. One of the major goals of this restructuring was to make sharing of settings amongst teams and disciplines easier, and the directory-based structure helps in this respect. A graphical user interface similar to ANZA is available now in Meta in order to handle all the default values found. So through this interface, it's possible to see the values set in each location. So the group directory, the home user directory, the project directory, etc. And we can also check the startup and current values of the default entry. For example, in the case shown here, we've got the current values of the annotations color and size being different to the startup values, and this can be seen in the drawn annotation of the 3D model. One note to make here regarding legacy: all legacy functionality will continue to work, so XML files of the previous format can still be read with a -XML option. Old meta post defaults files can still be read, and the toolbars referenced in these files can still be loaded, or commands placed between the session start and session end keywords of the default meta post defaults files can still be read. Now, with regards to scanning and loading specific contents from Abacus files, it's now possible to filter and load not only PIDs, but also sets, includes, ANZA comments, etc. from the input files. And further to that, specific PIDs may be scanned and loaded from ODB files as well. In the read results field, the functionality of excluding singularities around rigid elements has been taken one step further, allowing us to set specific types of elements around which elements should be excluded. So in this case, we can separately exclude elements around RBEs or RB2s. This functionality is available for all solvers. Another handy new feature is that we can ask Meta to recalculate the deformation scale factor automatically for specific parts and states. This is possible through the command line, and as a result, we can have different scale factors calculated on the fly for the visible parts. Now, in terms of handling results, it's possible to perform direct calculations between states from the context menu, either accessed from the states list or through the animation bar. By invoking the context menu, operations like finding the maximum or minimum between states or adding, subtracting results are very quick and direct to perform. In addition, it's possible to extrapolate results from some source nodes for which measured results are available, for example, to the rest of the structure, therefore getting an approximation of the results of the whole structure using that same context menu functionality. Now, as far as handling of states and animation is concerned, when the animation bar changes and shows results over time, new options are offered to allow synchronized animation between models with different time steps. For example, in case we have two models with different time steps, we can ask Meta to create interpolated states in one of the models in order to end up viewing the results in the exact same time step. In addition, this functionality can also be applicable in the case of a single model with a non-constant time step. In such a case, again, we can ask Meta to create interpolated states and view the animation as if the time step was constant. A new positioning mode is offered in the annotations tool. When this new dynamic positioning mode is enabled, the annotations are automatically repositioned during model handling. As a result, overlapping with the 3D model or with other annotations or entries such as fringe bars or the title is avoided, and intersections between the various annotations pointers are also avoided. Moving to the advanced filtering tool, local extremes or local minimum and local maximum values can now be identified from the tool. And further to that, the fifth field of this tool has been redesigned in order to offer more clarity and therefore be easier to handle. A new interface is available in the IsoFunctions tool, with simplicity and user-friendliness being top priorities. In these terms, there's a clear distinction of the tabs offering the different options in the relevant groups, and it's also more clear to understand the label by which an existing IsoFunction has been created. New options are offered in the creation of linear paths by projection in the parametric point paths tool. The projection direction can be defined as well as a maximum search radius. These two result in having much better control over the created projection points in cases with holes or openings, such as the ones shown, by avoiding redundant projections in unwanted areas. With regards to fringe contours, a new feature has been introduced which allows blending between results of no value and results with value. This factor affects the way the transition between these two areas will be visualized and can be adjusted accordingly to span over a percentage of the no value element. In this example, for instance, it's set to 50%, and as can be seen, the transition spans over half of the size of the element. The fringe bar titles can be directly associated now with the active label through an option offered in the fringe bar settings. This can be very useful in cases of multiple result sets, models, and windows, making it easier than before to control and keep track of what is being visualized at the time. For the visualization of vectors, a new option has been added to view the vectors in a uniform user-defined single color. So apart from the uniform size, which we already had so far, now we've got the uniform color option as well if needed. And furthermore, individual scale factors for vector deformation components have been introduced in the vector settings menu. A new type of sketch is now available in the sketch tool. This is a freehand sketch which gets attached to the nearest PIDs and stays attached during model handling. The difference can be seen here, where the red sketch has stayed attached to the PIDs when rotating the model, whereas the blue one hasn't. Markers are fully supported through the annotations tool. There are 3 different styles: stickers, flats, and spheres, and they are either available for creation on the fly through the annotations window or by a respective branch of commands. Also, markers from solver entities that are supported in Meta, such as Pamcras, SENPTG, can be controlled by the same branch of commands. With regards to the template manager, the window names of curves and calculated curves are now displayed in the template window for easier handling and a better overview. A new column has been added to the CSV file representing the visibility of curves, so this information is now stored in the CSV file as well. And in addition, it's possible to start Meta with a specific template and the needed arguments by using the running option -t followed by the template file and the respective arguments. It's worth to point out that the template manager has now been separated from the labels list, avoiding potential confusion. Just to be clear, the template manager serves as a tool for creating, reading, and handling templates, whereas the labels list can provide an overview of the loaded results per model. Now moving on to the 2D plot sector. Here we have introduced themes and display styles in order to be able to save them and later reapply them to other windows in order to avoid repetitive actions. Themes include purely visual options like selected colors, fonts, etc., whereas window or plot styles refer to the actual settings of the titles, ranges of the axis, legends, fringes, etc. The window and plot styles may or may not include the theme, so that most, if not all, preferences are met. The created styles can be exported in JSON format and imported back for future use. A new option has been added regarding axis ranges, where we can now reverse the axis range and have the chart starting from the opposite side of a plot. And another new feature in curves is that curves can now be recreated by Meta on the fly by editing the creation command. So this is available through the context menu and the curve options window. And we can copy one window that contains curves that refer to a particular node, and by editing the creation command and entering another node ID, we can then have Meta recalculate the curve on the fly for the new node that we define. Now moving to the various disciplines and starting with crashing safety. Here we've got some major performance improvements in reading time. So the loading time of ERF and ERF FemZip files has been accelerated, reaching up to 30 to 35% when it comes to loading both geometry and results. Furthermore, ERF FemZip version 11 has now been supported. Still on the reading time side of things, but this time for FemZip LS-DYNA, there has been a significant speed up in reading results for a single integration point in comparison to the previous versions. In addition, multi-selection of results is now possible, resulting again in improved reading time in comparison to loading each result individually. A new functionality has been introduced in comparing a simulation with a real test case video. With this functionality found in the Images and Videos tool, it's possible to rate the correlation between a simulation and a video, and therefore see how well these two correlate with each other. We've got one new toolbar introduced that produces reports with 3D results referring to human body models. The supported models so far are Global Human Body F05, M50, and M95. In the Occupant Injury Criteria toolbar, we also have results for two human body models, namely F05 and M50. And it's possible to compare results for these human body models with the existing anthropomorphic test devices. In addition, human body model results may be used in ratings as well. Still in the Occupant Injury Criteria toolbar, we've got newly supported ATDs, namely 450 for autonomous vehicles, Q3 child dummy, 405F, children ATDs age 3, 6, and 10-year-old, and CRABI 6 and CRABI 12. The China NCAP rating has been supported, and 450 for autonomous vehicles is supported in the US NCAP. Results of the Euro NCAP rating can be added in the official Euro NCAP spreadsheet. And lastly, it's possible to extract restraint results for the steering column, airbags, and seatbelts, but we need input spreadsheets to be created in order to extract these results. Now, with regards to new capabilities of the toolbar, cross-plot creation is available, so we can select the desired results and, for instance, have a force displacement plot created. It's possible to load the 3D model and request tiling between the 3D and the 2D plot windows. It's also possible to request the creation of annotations on minimum or maximum curve values. On top of that, SAE filters can be chosen upon plotting. Different unit systems can be requested for different types of results. Therefore, for instance, we can have accelerations in G and forces in kilonewton. And lastly, when results are read with follow nodes, this is now saved in the template produced. Moving on to the FMVSS toolbar, the graphical user interface has been redesigned, and it's now possible to run custom session files for the selected or picked target points. There's also a new option to overlay the custom session for the selected or picked points according to page ID or page name. And furthermore, a summary report can be created for the target points provided that the column report exists in the target points file. Another new toolbar has been added regarding far-side crash. It can be used to calculate the head excursion in far-side tests, and the maximum occupant score for Euro NCAP 2020 far-side test can be calculated. Moving on to the MPDB toolbar, there's the possibility to calculate results for many models at once. We can have statistics such as minimum, maximum, and average of each selected run. When compatibility assessment is performed for multiple models, the difference in the MPDB intrusions is calculated for each pair of selected models and can be presented as a scalar label. And lastly, the capability to calculate intrusions and compatibility score from deformed geometries such as scanned test results is also offered. Another new toolbar is available for the automatic report generation for FMVSS 581 and ECR42. With the aid of this toolbar, the maximum intrusion of the bumper cover and the maximum deflection of the back beam can be calculated. There have been some new developments in the pedestrian toolbar. The China NCAP has been supported, and there's the option to overlay points by name. So it's easier to compare target points that have the same names but are in different versions. Lastly, for the crash and safety field, impetus time history files can now be read directly as 2D plots. In kinetics, model geometries can be read directly through individual graphics files. And moving on to NVH, we now have direct support of enforced excitation on tire patches in the model response and FRF assembly tools. With this development, there is no need anymore to use the large mass method in the NVH console as was done so far. Shock response analysis is supported in the digital signal processing toolbar. The goal is to calculate the response under a shock excitation, which is a short, non-deterministic transient event in time. The solution is to build a shock response spectrum, which has the characteristics of the shock load, and apply this as a load in order to get the response result. The model response tool is now able to read poroelastic material matrices in model space from Nastran OP2 files. These are taken into account in the response calculation for systems with fluid structure interaction, and Meta calculates exactly the same FRF results as Nastran solution 111. The option to apply enforced excitation in transient response analysis is now given in the model response tool. For this purpose, a new column for type has been added in the transient response tab. This option serves applications of examining transient phenomena of components with enforced motion. A nice new feature which comes handy is the color coding of poles in the model parameter estimation tool and the stabilization diagram, making it easier to spot the ones of interest. And the Squeak and Rattle toolbar now supports Abacus and Nastran Solution 111. In the area of fatigue, FEMFAT FPS result files are now supported. And we've got Fourier and inverse Fourier transformations available for 3D results read from Nastran OP2 files. This functionality has been incorporated in the linear combination tool, so one can find it there and use it. A new field where Meta has expanded recently is the electromagnetics field. So electromagnetic results are supported in LS-DYNA, leading to the expansion of Meta in this field. Current density, electric field, magnetic field, Lorentz force, Randall results, and many more are some of the results that are supported as scalar and vector directly in Meta. In the CFD area, there have been some developments in the CFD post-processing toolbar, which has been redesigned. It provides a better and more comprehensive user interface that contains more functionality. Some of the new functionality includes enhancements in result calculation, generation of snapshot scenarios. So a snapshot scenario can contain, for instance, a cut plane that moves along the model in a predefined axis, taking snapshots in certain positions, or a set of views on which snapshots will be generated. And also we have a report generation available for the toolbar. SC flow format has been supported for polyhedral elements, and furthermore, plot3D files have been supported and can be read. Reading of multi-region cases has been enhanced, so decomposed cases containing fluid and solid regions can now be loaded in Meta, and the results can be visualized without problems. Converge v3 has changed its file format, implementing the new HDF5 structure, and Meta now supports reading this new H5 file format. With regards to particles visualization, the visibility of particles in areas of low particle density can be controlled by defining a percentage criterion. The percentage of mean concentration below which to hide particles can be set in the settings menu, resulting in avoiding the visualization of very few isolated elements. For model handling, the cut planes tool now offers the option to show complete solids at the cut plane interface. And furthermore, a cut plane can be animated along a predefined path, which is created beforehand using the parametric points path tool. With regards to flow paths, the option to restrict flow paths to a specific solid PID is made available by enabling or disabling the crossover PIDs option in the flow paths tool. Now, in composites, there have been some developments in the composite post toolbar where PAMCrush lay plot results from ERF files are now supported. So PAMCrush is now added as an option in the available file formats. In addition, creation of 2D failure envelope plots for Tsai Wu, Hill, Hoffman, and Max stress criteria is now available. The appropriate option can be selected and the new plot will be produced. The full stress tensor can now read extended 2D stresses for second order square single curvature shells. In order for these results to be calculated correctly, a Nastran OP2 file with deformations is required as input. In the area of reporting, annotations can now be exported in View3D PDF files, and as can be seen, model rotation can be performed with the annotations properly following the elements they point at. This enhances the exporting in 3D PDF files, which are a quick and easy way of exchanging information about models among the users. New file formats are supported in exporting the 3D model, namely GLTF and the GLB formats are available. GLB is a binary format and it can be embedded in a PowerPoint as long as it's 2019 or 365 version. And also GLB files are supported in the Report Composer tool as well. In the area of report automation, a new class has been introduced with methods that add tags to reports, slides, and slide elements. In addition, the report finder functionality is now also available through script, apart from only being available through the graphical user interface. So now it's easy to create a script which adds tags to reports and report elements, as mentioned before. And then by using the report filter object, one can find PPTX files based on their tags within a specified directory. In data management, a new report type named plot has been supported. This type includes all data relevant to a 2D window, so the curve settings, the plot settings, etc. And plot report items are saved to DM when recording a meta session for simulation run and 2D windows are created, or when using the DM add plot session command. Keeping up with the advancements in the MetaDB file format, the functionality to use the MetaDB as a solver file and therefore calculate derivative results is now available for more solvers, namely ANSYS, PERMAS, OpenFOAM, and StarCCM+. It's reminded that in previous versions this was already made available for LSDyna, Nastran, and Abacus. MetaDB files or project files can be scanned for PIDs using the latest filtering mechanisms introduced in the previous major versions. This functionality is available either through the read results part or the project contents browser. And taking this one step further, the project contents browser can now scan results as well, providing the opportunity to filter and load only specific results from a saved project file. Now, in the area of process automation, we've got some enhancements in the MetaPython API with the extensive use of named arguments and the support of using meta objects as arguments. For example, in cases where previously we had to create the element IDs or types and give them as arguments, now we can use directly the objects, resulting in simpler syntax. A new license is available for scripting purposes, so there's no need to acquire a full license since this type is intended for the use of the Meta API. However, in these terms, some limitations apply in cases for models with more than 1,000 elements or curves with more than 50 points. Now let's move to the various keywords and the features supported in each of the individual solvers upon demand, starting with Abacus. We have Abacus 2020 supported. Analytical surfaces can be read from ODB files. PC3D elements can be visualized as fluids. The visualization of Abacus fasteners and their connected elements is available through the focus buttons. Strange-free results are now detected when scanning an ODB file. The width of an analytical surface is read from the ANSA comments. And the S positive and negative options of the shell section cards are supported. Moving to LSDyna, curves can be read from RVOut ASCII files and trace particle history files. Plastic and thermal strain tensor results are available. We already mentioned the support of electromagnetic results. SPC resultant forces are now supported as set SPC force in 2D plots. Failure and failing time for SPR2 elements is supported. A series of keywords, set option, collect option, element mass part set, and load node keywords are available. And lastly, the follow node displacement from port has been repositioned in the list in the read result card. So everyone is acquainted with the existence of this option as well as the simple follow node displacement option in order for the correct one to be chosen depending on the case. In PERMAS, results related to acoustics are now available. Beam type element force results are supported in scalar and vector under beam forces. And nodal point results are available as vector plots as well. In Medina, SK, FE, and P and the range of new element types have been made available. Animator databases can be read as projects in Meta, where results are loaded as label. The current state and label for every model and window is preserved. Animator views are shown as windows. The visibility can be per PID. Entity identification per model for each window will be preserved. Cut planes will be loaded per model for every window, and texts can be displayed as annotations. Exploded PIDs are handled as such, and there's lately a significant performance improvement in reading of multiple models. In ANSYS, geometry can be read from ANSYS 2021 RST files. In PAMPRAS, SNPT elements can be read and displayed from ERFH5 files. FMP results are supported as vectors. In ACTRAN, we've got native EDAT files supported. And in ADAMS, AMD files referenced inside CMF files can be read, and 2D results of type requests have been added. In SONATE, power injection results are supported. In ENCODE, we have results read from FAIR files. New element types and new element classes supported in MARC, and sets from T16 files are read correctly. Reading of Plotel 3 and 4 elements of NX Nastran and Octastruct is available. Moving to OpenFOAM, it's possible to display OpenFOAM partitions when cell-based results are not available. Reading of OpenFOAM times converted results files is supported. In Fluent, species mass fraction results are available, and the reading time of that results files has been improved. Particle tracks in ENSITE format are supported. And in FEMFAD, we've got detailed weld node information visualized through the identify node function. Last but not least, in Hyperview, 2020 libraries of H3D file format have been supported. Moving now to collaboration. We've got some enhancements in the collaboration through web interface, where pages, windows, and states are now supported when operating Meta through a web browser. And it's also possible to control the visibility of a model by the operators of a web session. In virtual reality, we've got the support of personal avatars of FBX format with mesh and skeletal rig. In order for all parties to be able to view the avatars of each other, the avatar files need to be placed in the same absolute or DM path, similar to how the collaboration models are placed in one of these locations. A new mode is available, the presenters mode in collaboration. When this mode is activated, the ray of each member becomes visible to the other members of the collaboration, so it's possible to highlight areas of interest on models and on overlays, such as a 2D plot. And through that same presenters mode, the tablet becomes shared with the other members of the team, so it's easy to guide other collaborators through the VR functionalities by directly showing them where to press on their tablet. Avatars in immediate proximity are turned semi-transparent in order to avoid obstructing the view of other collaborators when they're standing in front of the model, such as the case shown. In the CFD post-processing applications inside VR, we can now interactively create the streamlines from lines or planes. So in addition to point streamlines, which we used to have inside VR. And a new mode is also offered that clones streamlines to all exploded models for easier model comparison. Multiple overlays can be viewed simultaneously in VR, so we can have many plots, images, videos, reports shown at the same time. And also videos can be animated in parallel as well. We've got a newly designed gizmo for exploding the model or the 2D overlays. It's much more intuitive than before, so with the trigger of the controllers, we can select the axis we want and move or rotate the model accordingly. We've got newly designed icons serving as tooltips and notifications inside VR to enhance the user experience. If there's a user who is joining the collaboration through desktop without a VR headset, they can activate their pointer from the collaboration tool, and then the VR users can see where exactly the desktop users are pointing on the model. We've got access to the desktop workstation as a separate overlay inside VR, so one doesn't have to take off the glasses. Voice-to-text dictation is available instead of using the virtual keyboard in the sketch annotations and the to-do list tool. A new family of headsets has been supported, the Windows Mixed Reality headsets, and tooltips and buttons mapping is provided for these headsets as well. Now, as already mentioned in the ANSA presentation, the Python version of Beta CA Software Suite has been upgraded to Python 3.8.1 with all the key changes and upgrades such as upgraded libraries, new class types, SciPy and H5Py included in the distribution package. And one last technical update regarding the installers. The beta installers have now been split in two parts. The first part contains everything except the external libraries that Meta needs to read Abacus files. These are provided in a separate installer, which provides reading capabilities for Abacus files from version 6.13 to the most current one. Previously installed libraries will continue to function with the new Meta versions. However, if a new version of Abacus is supported with Meta, then the respective libraries will only be provided in that specific installer.